One of the biggest misconceptions in software development is that good software developers write a lot of code fast. Sure, you can't have a product without building it first. And people tend to want their projects built as fast as possible and as cheaply as possible. This is now more obvious than ever, since everybody is so excited to see LLMs generate thousands of lines of code based on a simple prompt. But, in general, measuring lines of code is one of the dumbest ways to assess progress or skill. Because I would argue that the person going through 20 entities line by line, instead of using a for loop, isn't that skillful. Or, looking at an example closer to home, a developer using Node.js, Next.js, React Server Components, and a bunch of other libraries to simply build a 3-page static website isn't smarter than somebody building it with just some plain HTML and JavaScript. And here is the actual truth. Good software development isn't about adding code and complexity, it's about removing code and complexity. And, trust me, this is going to be one of the most valuable skills in the near future once people with no real technical understanding pile up more and more AI-generated code in their projects. Someone will need to clean that up, make sense of it, and keep it from collapsing under its own weight. So on this Monday morning review, we look at the importance of simplicity and the dangers of hidden complexity. I know that Anthropic employees keep promising that AI-generated code will be as reliable as compiled code, but anyone with a minimal understanding of how these large language models actually work knows that's an outrageous statement. These models are just auto-completing patterns, and sure, sometimes that pattern lines up with what you need. But most of the time it doesn't, and comparing an unpredictable slot machine spitting out code with the fully predictable and controlled process of actually compiling is just absurd. But let's get back to the idea of simplicity. When we started in the industry, we all thought that programming is about building. You sit down, you write code, and you produce something. Then you sell it for $1 billion and start fighting UFC champions. Then you realize your Facebook clone isn't going to take off, and you actually had to get good at coding. And if you stay in the field long enough, you realize that writing code isn't the hard part. The real skill is knowing what to remove. If you ask any experienced developer about it, they'll tell you that they spend more time reviewing code and deciding what shouldn't be there than writing anything new. Half the time, they are just untangling something that used to make sense but no longer fits the direction of the project. And, while this might sound easy on paper, trust me, it's actually really hard because to get to the point where you can simplify a codebase, you actually have to put in the work, know your basics, and go through the process of actually writing shitty code first. But to really illustrate this, let's look at a practical example. I recently found this article explaining the incredible overcomplexity of the ShadCN radio button. For those unfamiliar with it, ShadCN is essentially a collection of pre-built UI components that you copy directly into your project. The idea sounds reasonable and got pretty popular in some front-end circles. Instead of installing a heavy UI framework and fighting its opinions, you get a set of components you can own, modify, and adapt to your own design system. But, as you guys know, the web devs are famous for delegating even the most trivial task to some obscure NPM package, so, naturally, underneath ShadCN sits another library called Radix, which provides the actual interaction logic. So what looks like a simple radio button is already 2 abstraction layers deep before you even open the browser. At this point, the original problem has quietly disappeared. Nobody is asking how to render a radio button anymore. The question has become how to integrate multiple abstraction layers that together simulate something the browser already knows how to do. The exported ShadCN component looks harmless at first glance. A few imports, some Tailwind classes, a wrapper component. But then you notice the dependencies. Radix primitives, an icon library just to draw a small circle, utility helpers for class merging, React wrappers around other React wrappers. When you inspect the output in the browser, the illusion becomes obvious. Instead of a native radio input, you get a button element pretending to be a radio button. ARIA roles are added to tell assistive technologies what this element is supposed to represent, the state is synchronized manually, keyboard behavior and focus handling, and somewhere inside all of this, hidden away, there's still an actual input radio. This complexity is really dangerous because nothing here looks wrong in isolation. Sure, accessibility matters, consistent styling is important, and reusability is a best practice in software development. But each layer assumes responsibility for behavior that was previously free. The browser already solved grouping behavior, keyboard navigation, form submission, and accessibility semantics. By replacing the native element, the library now has to simulate decades of accumulated behavior. And remember that all this complexity is usually justified by styling. Historically, form controls were inconsistent across browsers and difficult to customize. So libraries started rebuilding them from scratch to gain full visual control. The problem is that this assumption is outdated. Modern CSS allows radio buttons to be styled directly by removing the default styling and leveraging pseudo elements and the checked state to show and hide visual indicators without replacing the underlying element. This is a classic anti-pattern where a system is so customizable that it ends up becoming a poor replica of the platform it's built on. Before talking about some of the solutions, please let me tell you a few words about today's sponsor. Ever feel like you are flying blind when your app slows down? You check the logs, scan the dashboards, and still can't tell if it's the database, the network, or the code. That's when MongoDB Atlas turns on the lights. With built-in observability and new interoperability features, Atlas helps you see exactly what's happening and why across your entire data layer. You can analyze slow queries in real time. That is to say, sub-second updates, monitor performance trends over extended duration, and stream metrics to tools like Datadog or Splunk for a unified full-stack view. Less finger-pointing and blame games, more root cause identification and problem-solving. Please check the link in the description to see how modern teams get clarity with MongoDB Atlas observability. Back to the video, these days we complain about the AI-generated slop, but if we are being honest, most of the code we produce is no better. There is this concept called zero-cost abstraction, popular in lower-level languages like Rust, which states that you should be able to use a higher-level abstraction without paying a performance penalty at runtime compared to writing the raw low-level code yourself. If a simple UI component requires 50 KB of JavaScript to mimic a 1 KB native element, then the abstraction is just hidden cost you'll end up paying eventually. In the book A Philosophy of Software Design by John Osterhout, there is an important distinction being made between deep modules and shallow modules. A deep module is one that provides powerful functionality through a simple, tiny interface. Think of the Unix file system, which is just a handful of system calls like open, read, and write. Underneath those simple commands lies a mountain of logic handling disk drivers, caching, and file systems. So a deep module implies low mental overhead for the developer, high value for the product. What we're doing with things like the SHAD-C and radio button is the exact opposite. We are building shallow modules where we are creating an interface that is complex to look at, complex to import, and complex to maintain, but it doesn't actually provide any deep functionality. It's just a paper-thin wrapper around a problem the browser already solved for us back in 1995. Joel Spolsky once wrote about the lore of leaky abstractions, which says that all non-trivial abstractions, to some degree, leak. When your simple radio button component fails to submit in a standard HTML form because the library author forgot to sync the internal state to the hidden input, that's a leak. When you spend 4 hours debugging why a mobile screen reader won't click your custom button, you are paying the tax on an abstraction that promised to save you time. And since we are talking about over-engineered solutions, here is your awesome trivia for the day.
Trivia in 10 seconds.
Legend has it that back in the 60s, NASA realized pens wouldn't work in zero gravity. So, they spent millions of dollars and years of research developing a pressurized ink cartridge that could write upside down, on grease, and in extreme temperatures. Meanwhile, as the joke goes, the Soviets just used a pencil. Now, the real story is even more interesting for us as developers. NASA actually did try pencils, but they realized the broken graphite tips and flammable wood dust were a lethal hazard in a high-oxygen capsule. They needed the complexity of the pen because the space was too hostile for the simple tool. Back to the video, the chances are none of us are building software for space. And, with seniority and experience, developers realize that their software engineering role is shifting from building to editing. In other words, software engineering is becoming less about construction and more about curation. The junior views a blank text editor as a canvas to be filled. The senior sees the codebase as a garden that is constantly trying to grow over with weeds. If you aren't actively pruning, the weeds will eventually choke the life out of the actual product. If you liked this video, you should consider joining our community where I'm posting more dedicated weekly content. Please don't forget to smash all the buttons, and until next time, thank you for watching.